All right, 5.2 is verifying trigonometric identities. It says guidelines. Work with one side of the equation at a time. It is often better to work with the more complicated side first. Look for opportunities to factor an expression, add fractions, or create a denominator with a single term. Look for opportunities to use the fundamental identities. Note that the functions that should note the functions that should be in the final expression. Sines and cosines pair well, as do secants and tangents, and cosecants and cotangents. When the preceding guidelines do not help, try converting all terms to sines and cosines. Always try something. Even making an attempt that leads to a dead end can provide insight. So when it says we need to verify the identity, we want to prove that the left hand side equals the right hand side or the right hand side equals the left hand side. So one of the guidelines is it is better to work with the more complicated side first. That's number one. So which side looks like the more complicated side to you? The left hand side or the right hand side?
The left.
Definitely the left side. All right. We got to prove this. Any identities, maybe, that you can see we can work with? And we can see what happens. You just throw some out there and see what we can do with it.
Could we turn a secant into a 1 over cosine?
All right. Secant and 1 over cosine. All right. Let's see. Let's see. So this put this on scratch paper because I don't know how we're about to go. All right. So you're saying top and bottom. So let's put left hand side. So put this on your scratch paper, not on your real paper, y'all. 1 over cosine squared theta minus 1 over cosine 1 over cosine squared theta. All right, what would you do next then? If we started with that on.
I do not know.
Okay. All right. That would mean that the only thing I can see is that in the top we can put this together. So that would be cosine squared theta over cosine squared theta. Let's see what happens. So that's 1 over cosine squared theta minus cosine squared theta. So that's 1 minus cosine squared theta over cosine squared theta over 1 minus cosine squared theta. Hmm. Okay, okay. I see some, Owen. When you simplify this, what happens? Can y'all simplify that and tell me what happens? I see a path. I see a path, Owen.
Could you cancel out the cosine squared theta in the denominators of both fractions?
You said cancel?
Yes, ma'am.
Yes. All right. These cancel. So that leaves you with 1 minus cosine squared theta over 1, right? Which is that. Okay. How does this 1 minus cosine squared theta equal sine squared theta?
It's it's close to your favorite.
It's close to my favorite. All right. So my favorite is sine squared theta plus cosine squared theta equals 1. And if I wanted to make it look like that, I would subtract cosine squared theta on both sides. That cancels that out. Sine squared theta equals 1 minus cosine squared theta, which equals sine squared theta, which equals the right hand side. It worked, Owen. It's so many different ways that it could work, though. That's why I wanted you to tell me. Throw something out there, see if it will work. Um, I use tan squared theta for mine. So I'll just show you one more way just to prove that you don't have to be pigeonholed to one way. But WebAssign may ask you to go one path. So you're going to have to follow the path that WebAssign is asking you to go in. But it's not one way, just one way to prove it. Just for the homework's sake, they wanted to see if you can follow their path. Okay, so I'm going to do a alternative way. Alternative. So left hand side equals secant squared theta minus 1 over secant squared theta. Now, according to our identities, 1 plus tan squared theta equals secant squared theta. And if we want to figure out what is secant squared theta minus 1 is equal to, we subtract 1 from both sides here. So that's tan squared theta equal to secant squared theta minus 1. So that's tan squared theta over secant squared theta. All right. Next, let's break down tan squared theta and secant squared theta. So for example, we know that this is the same thing as tan squared theta times 1 over secant squared theta. So I kind of split them up a little bit so they're not right under each other just to kind of break it up. Tan squared theta we know is the same thing as sine squared theta over cosine squared theta. And what do we know secant squared theta is equivalent to? What about secant? What do we know that secant, just secant theta then? What is secant theta equivalent to?
1 over cosine.
1 over cosine, so 1 over cosine. So if it's secant squared theta, then we got to put cosine squared theta, right? So that's sine squared theta over cosine squared theta. That's going to flip to cosine squared theta over 1. And then you can cancel out the cosines, leaving with sine squared theta. All right, so another way to get to the right hand side. All right, but you got to know these identities. You got to be real familiar with them. All right. Verify the identity. Which side looks the most complicated to you? The left side or the right side?
Left.
Left, definitely. All right. Verify the identity. Sine squared theta plus cosine squared theta over cosine squared theta times secant squared theta. What do y'all think? What are your recommendations on how we can definitely left side? How can we? We're gonna start with the left side first. What do y'all want to do first? We gotta prove that it equals 1. Any suggestions? All right. Does the top part not look a little familiar, y'all? Just a little familiar?
It's your favorite one.
It's my favorite one. Y'all don't like mine. So I see that now. See, y'all don't like my favorite identity. All right. But that, what is sine squared theta plus cosine squared theta equal to?
1.
1.
1. So we at least get it down that numerator to 1, at least. All right. I put a plus sign, but it's supposed to be a times. All right, so we got cosine squared theta. And what do we know secant squared theta is equal to?
1 over cosine.
But and so if it's secant squared theta, what is it equal to? Not secant theta, but secant squared theta, what is it equal to? I didn't say secant, I said secant squared. Then what would it be equal
1
to?
over cosine squared.
Uh-huh. All right. So then when those two counts out, then we get to 1 real quick. All right. That probably blew y'all mind. Y'all like, what? What just happened? Yeah, it was simple for some reason. But just try something, throw some stuff in there, see if it works out. It may not, it may not. But attempt something. All right, here, verify the identity. 2 secant squared alpha equals 1 over 1 minus sine alpha plus 1 over 1 plus sine alpha. Which side seems like the most complicated side to you? Which
Both.
side?
The
Both?
right hand
I said the
side.
most complicated. Right hand side. All right. So we're going to start with the right side. So and let's attempt to add this together. So what do we need to, it's not theta anymore, it's alpha. Alpha. What do we need to add fractions together? What do we need to add fractions together?
Common denominator.
Common denominator. Anyone tell me what is the common denominator?
This is the 1 minus sine
Yeah, one of
and
them
the
supposed to
1.
be plus. Yeah, I ain't write that right. One of them supposed to be plus. Yep, both of them. All right, so this side needs 1 plus sine alpha, top and bottom. And this side needs 1 minus sine alpha, top and bottom. So we at least know that our denominator is 1 minus sine alpha times 1 plus sine alpha. And every once in a while, you gotta look on the see what are you supposed to be getting this to equal to. Just kind of peek at it a little bit, trying to figure out how we're gonna make this happen. All right, now 1 times that, that's 1 plus sine alpha plus 1 times this is 1 minus sine alpha. Can it? Is there any way we can clean that up right quick that'll help us out? Anything you see we can clean up a little bit before we move on?
Can you cross them out?
Cross it out.
The 1 minus sine alpha and the 1 plus sine alpha.
Does 1 plus 1 cross out?
Oh no, the subtract.
Okay, okay, you gotta be careful now. It's not 1 plus 1 is 2, right? So
Yes.
this cancels out. We got 2 over. Now, if we multiply 1 minus sine alpha times 1 plus sine alpha in the denominator, what will we get? Now, we do have a 2. Y'all see that 2? And we pick back up at what we're supposed to be equaling to. We do find a 2 is popped up. All right, so, but I want y'all to multiply the denominator and tell me what you get.
One minus sine squared alpha.
Yes, 1 minus sine squared alpha because the middles are going to cancel out. Now, with that 1 minus sine squared something always shows up, is it equivalent to something? Or does it look like an identity that you may be familiar with? I don't know. But it does look like my favorite, right? So, given sine squared, let's put alpha, plus cosine squared alpha equals 1. Let's see, can I make it look like this? What would I need to do so that we we get 1 minus sine squared alpha? What would we need to do?
Check the
To
sine square alpha from both sides, or the x on both sides.
say it again.
Subtract the sine
Okay, subtract the
square.
sine squared. Okay, got it. Minus sine squared alpha. That cancels. So that's equivalent to cosine squared alpha. Okay, so that's 2 over cosine squared alpha. Okay, we're getting close. How can I get it to be 2 secant squared alpha? Can anybody see what's how we can get it to 2 secant squared alpha? Show it paper how we can get there. Okay, here's how you do it. You separate it. This is the same thing as 2 times 1 over cosine squared alpha, right? So that's 2 times, what do we know 1 over cosine squared alpha to equal?
Just the secant
This
square alpha, right?
squared alpha, right? Yep. So that's why the final answer is 2 secant squared alpha, which is the not the right hand side this time. We actually started with the right hand side and we proved that it equals the left hand side. All right, we're going to try one more. So take a picture of that if you don't have it. Yeah, we can't finish today, I see. All right. Verify the identity. Which side do you think we should work with first?
The left hand side.
Left hand side. I agree. I would agree. Left hand side. Does anything look familiar? We got a tan squared x plus 1, and we got a cosine squared x minus 1. Anything y'all see that looks familiar to those things when you look at your identities?
The cosine squared x minus 1, you can use your favorite
Uh huh.
identity
Uh
to
huh. And then, yep. So for this one, sine squared x plus cosine squared x equals 1. How can I get it to be cosine squared x minus 1 though? So what would I need to, how would I need to move things around so I get cosine squared x minus 1?
and subtract the 1 on both sides, and
Correct.
then um, you'll subtract the sine squared x on both sides.
Correct. I'm going to go ahead and do it in one swoop. So it'll end up being cosine squared x minus 1 equals negative sine squared x. Good. What about the tan squared x plus 1? Does that look familiar to anybody? Does that look
Does it
familiar?
equal cosecant squared x?
Look at it again. So I can tell y'all don't have y'all stuff printed out because I don't have it on 5.2. It's on 5.1. All right. So tan, anybody with the notes? What does tan squared x plus 1 equal to?
secant squared x.
Secant squared x equals to, I'm going to rewrite this back over. Tan squared x plus 1 times cosine squared x minus 1. We said that equals to secant squared x times negative sine squared x. So we did that. What do we know secant squared x is equal to?
1 over cosine squared x.
hmm So secant squared x would be 1 over cosine squared x. All right, times this. If we multiply both of these together, it would be negative sine squared x over cosine squared x. Then we got to peek at where we supposed to, the right-hand side is negative tan squared x. So the question is sine squared x over cosine squared x the same thing as tan squared x? Is it? Is sine squared x over cosine squared x tan squared x?
Yes.
Yes. All right. So that's why you got to peek at what the answers you're supposed to go so you know you're on the right track. So negative tan squared x, that equals our right hand side, and we have proven that the left hand side equals the right hand side. Verify each identity. So for A, which side in your opinion looks like the more complicated side?
B.
Okay, what did y'all say? For A, which side is the most complicated side to you?
The left side?
Left side? Okay, yes, work on that. So for A, let's look at the left-hand side, which is tan x cosecant x. And eventually we want to get to prove that that equals secant x. So let's break down tan x and cosecant x. What do you know about tan x? What can we replace tan x with?
Sine over cosine.
Sine over cosine, and then cosecant is what over what?
One over sine.
1 over sine x. So the sine x cancel, leaving us with 1 over cosine x. And what do we know 1 over cosine x to be?
Secant.
All right. All right. So I always kind of have an idea of what's on the right side so that it won't be so hard to figure out what it is. Yes, that's what we wanted it to eventually equal, was secant x. All right. And that's the right hand side. So we're good with A. Let's look at B. All right, so let's go with the left-hand side equals tan x plus cotangent x. All right, we just said tan x was sine x over cosine x. What is cotangent x then? If tangent is sine over cosine, what is cotangent?
Cosine over sine.
Cosine over sine. So let's attempt to add the fractions together. In order to add fractions, we need a common denominator. So our common denominator would be cosine x sine x. So we definitely need a sine x on this side. So we're going to multiply the numerator and denominator by sine x. And on this side, we need a cosine x. So far, our denominator is cosine x times sine x. We have sine x times sine x, which is sine squared x, plus cosine x times another cosine x, which is cosine squared x. All right, does anything look familiar to you? After Tuesday, now that we have done many of these, does anything look familiar to you?
The numerator is 1.
The numerator equals 1. Yes, that's one of our Pythagorean identities. So we can replace that numerator with 1. All right, we want this to equal secant and cosecant. So it looks like we're getting there. We got that 1 at the top, and we got the cosine and sine at the bottom. We just need to separate this as 2 fractions, 1 over cosine x times 1 over sine x. It's the same thing as 1 over cosine x sine x. And we see now that that 1 cosine x will give us what part of the answer? 1 over cosine is the same thing as
Secant.
secant x. And then that 1 over sine x is the same thing as cosecant. Yes. So we proved it there that because that equals the right hand side. All right, any questions so far? All right, next, example 5. Verify the identity. Secant x plus tan x equals cosine x over 1 minus sine x. This time, let's start with the right side first. Right hand side equals cosine x over 1 minus sine x. All right, at this point, I want y'all, when you see something like this, use the conjugate of the denominator. So we have 1 minus sine x. What is the conjugate of 1 minus sine x?
1
1
plus
plus sine x.
Correct. So we're going to multiply the numerator and denominator by the conjugate 1 plus sine x and see what happens. Okay, so in the denominator, we're going to get that 1, and you're going to see it's going to cancel out. I'm going to multiply everything right now. I'm going to FOIL out everything so y'all can see. This is like a difference of squares, so it's going to, the middles will cancel out eventually. So plus sine x minus sine x minus sine squared x. Then you have at the top cosine x plus cosine x sine x. Notice the middles cancel out in the denominator. So now we have a cosine x plus cosine x sine x over 1 minus sine squared x. So I'm looking at the denominator. What can we replace 1 minus sine squared x with is the question. What do y'all think? When you see that 1 minus sine squared x, what do you think of? Say it again. Somebody say something.
cosine squared x.
Okay. Cosine squared x. Yes. All right. Because our Pythagorean identity, again, is sine squared x plus cosine squared x, or at least one of the, there are 3, but one of them is this. And if we wanted to get 1 minus sine squared x, what we'll need to do here is subtract the sine squared x from both sides. That'll leave us with cosine squared x equals 1 minus sine squared x. So that looks like what I want.
So we can at least replace the denominator with cosine squared x. All right. So we still hadn't made it because we need to figure out how do we get to secant x plus tan x. Secant x plus tan x. Does anybody see anything? That we can do now? What would you do now? Do y'all see it yet? All right, so all you have to do now is just split it up. You put cosine x over cosine squared x, and you put cosine x sine x over cosine squared x. All right, how do you simplify cosine x over cosine squared x? What's cosine x, Owen?
Take away a cosine from both to leave 1 over cosine.
Correct, because it's like x over x squared. You cancel out one x, top and bottom. All right, so this is gonna, if you cancel out one cosine, it leave us with 1 over cosine x. Same thing here, kind of cancel out one of the cosines, and you have a cosine x at the bottom, but you still have that sine x at the top. You just cancel one of the cosine x's, top and bottom. And then now we see that 1 over cosine x will give us the secant x we were looking for. And the sine x over cosine x is giving us the tan x we were looking for. So we're just verifying. We know it's true. They're telling us to verify, prove that it's true. So that's what we're doing. We're not solving anything. We're proving something. Using the identities we've learned and other techniques. All right, it says verify the identity cotangent squared theta over 1 plus cosecant theta equals 1 minus sine theta over sine theta. Both of them look like a lot, but which side you think we should work with first? Which is a little bit slightly more complicated?
Left.
Left. I think the left side too. All right, so what we're going to do is we're going to use an identity. There are a couple ways you can do this one. Let me try one way, and then if y'all don't like that, we'll try another way. Okay. Cotangent squared theta. Is there an identity that has cotangent squared theta in it? And maybe with cosecant theta? Is there an identity?
1 plus cotangent squared equals cosecant squared.
1 plus cotangent squared theta equal, you said cosecant squared theta. That means we can solve for cotangent squared theta. So I want y'all to solve for cotangent squared theta while I write down this denominator. So cotangent squared theta is equal to what based off of this Pythagorean identity?
1 plus, cosecant minus 1.
Yes. Okay, we're going to subtract 1, subtract 1. cotangent squared theta equals cosecant squared theta minus 1. Cosecant squared theta minus 1 over 1 plus cosecant theta. All right. Okay. This might be the better way. All right, now cosecant theta minus 1. That looks kind of familiar. Does it remind you of anything that you can do? Or what are your suggestions right now? And you may not know. Just the trail, what you think?
The first part, the first identity, your favorite one?
No, I mean, you said my favorite one, that's sine squared theta plus cosine squared theta, right? So no, it's not an identity per se. It's not an identity that I want y'all to think about. It's some other technique we can use to simplify this fraction right here. A rational expression, however y'all want to say it.
Could you cancel out the cosecants?
No, because it has a minus 1 and a 1 plus something. You can't cancel things out. You can't cancel terms out. Just say that. What can you? What do you say, Michaela?
The conjugate of it?
That, let me see. You think about that. That might get to where we want to go, but I think this would be easier. Why not factor the numerator? All right. So imagine that cosecant theta being an x squared, right? So don't y'all know how to factor x squared minus 1? What are the factors for x squared minus 1?
X plus 1, X minus 1?
No.
Correct.
Let me tell you something.
So this would be cosecant theta plus 1 times cosecant theta minus 1 over 1 plus cosecant theta. These are the same, so they cancel. All right. All right, that leaves us with, let me come down here. Cosecant theta minus 1. That's not that. So we're still not done. Well, we do know that cosecant is, what's cosecant the same thing as?
1 over sine.
1 over sine theta. So we're getting there. All right, we got 1 over sine theta. So what do y'all think we need to do now to get it to where we need to go? It looks like all we have to do is combine the fractions. All right, LCD, whatever. So that's over 1. So we'll multiply that by sine theta, sine theta. So you'll get that 1 minus sine theta over sine theta, which is the right-hand side. Now, that's not the only way to get there. Michaela, try the other way and see if it works. It may take longer to get there, but sometimes you still get to the same answer. It may take a little longer. All right, going to last page. Verify each identity. Tangent fourth of x. Tangent to the fourth power this time equals tangent squared x, secant squared x minus tangent squared x. All right, we're going to go with the right-hand side for A. which is tangent squared x secant squared x minus tangent squared x. I'm noticing that tangent squared x is showing up twice, two different terms. So let's factor it out. So that's tangent squared x times. If I factor out a secant squared x, tangent squared x from both of these terms, what would be left over? What would be the other factor?
Is it the secant squared x minus 1?
Correct. Minus 1. That secant squared x looks a little familiar. All right. Tangent squared x, we have secant squared x minus 1. We're trying to get to tangent fourth of x. Tangent to the fourth power of x. Secant squared x minus 1. What y'all think about that one?
The second Pythagorean identity.
Which is? Tell me what it is.
Square x.
1 plus tan squared x equals secant squared x.
Very nice. And then so we can subtract 1 to get it to look like what we want. So tan squared x equals secant squared x minus 1. So we can replace this with a tan squared x. We got the first tan squared x. And we got the second tan squared x, which gives us our tan to the fourth power of x, which is our left hand side. All right. B, we got cosecant to the fourth of x times cotangent x equals cosecant squared x times cotangent x plus cotangent to the cube of x. Let me put right hand side. We did the right hand side over here first. And so B, the right hand side looks a little bit more complicated to me. Right hand side equals cosecant squared x times cotangent x plus cotangent to the cube of x. Cube of x. And we're trying to get to be cosecant to the 4 and cotangent. Okay. All right. So what do we know about cosecant square x? Let's replace it. What do we know about cosecant squared x?
One plus cotangent squared x.
Okay. 1 plus cotangent squared of x equals cosecant squared x. So let's replace that with 1 plus cotangent squared x. Then it looks like now we need the 4 because we have a binomial times a binomial. That's 1 times cotangent x, 1 times cotangent cube of x. Cotangent squared of x times another cotangent of x is another cotangent cube of x. And then cotangent squared of x times cotangent cube of x is cotangent to the 5th power of x. All right, what can you do at this point to simplify what we just wrote?
Add the like terms.
Add like terms. Yes. That's 2 cotangent cube of x plus cotangent to the 5th power of x. Now, what are we trying to get it to look like? We got cosecant to the 4th x and cotangent. Okay. Well, Cotangent is in every term, so we can at least, since that's just by itself, we can at least factor it out. It's in every term, cotangent. So let's factor out one cotangent. Cotangent of x times 1 plus 2 cotangent squared x plus cotangent the fourth of x. So this looks like a backwards trinomial or backwards quadratic to me. So if we wrote it in the descending order way, it would be cotangent to the fourth x plus 2 cotangent squared x plus 1. And if we let u equals cotangent, then that would be u to the fourth plus 2u squared plus 1. All right. Is that factorable? Is u to the fourth power plus 2u squared plus 1 factorable? Is this factorable?
Yes.
Yes, it is. All right, the factors are u squared plus 1 times u squared plus 1. And if so, then this is, if we substitute our cotangent back into our u, then the factors are cotangent squared x plus 1 times cotangent squared x plus 1. Okay. And what do we know that cotangent squared of x plus 1 is equal to? According to our identities. Cotangent squared x plus 1 is equal to what?
Secant squared x.
Yep. We put it right here, right? It's at the top over here. We already have written it, that cosecant squared x is equal to 1 plus cotangent squared x. So cosecant squared x times another cosecant squared x will give us that cosecant to the fourth power of x, which is equivalent to the right-hand side. All right. All right. I'm going to go over one more that was on the homework assignment that wasn't in the book examples, but I feel like we need to go over it because I wanted to throw you off. All right, so this one, again, verify. All right, verify ... So we have 5 secant squared y minus 5 cotangent squared of pi over 2 minus y equals 5. Which, I go back through all the identities we talked about from 5.1. Which of those identities looks somewhat familiar or similar to this? Five point one that we haven't even talked about. We haven't even talked about it before. Which are the identities?
The co-function identities?
The co-function identities. Yes, the co-function identities. All right, co-function. There are 6 of them from 5.1. If you look at your semi-guided notes, you can open up the semi-guided notes from Canvas and look at the 5.1. I got all the identities on the first section, in the first section. All right, so which co-function identity do you think we need to use? Which one is the most similar to this one?
Cotangent pi over 2 minus y equals tan u, or tan y.
And now since ours is squared, what do you think we got to do with ours? What do you think we had to do with the tan y? If this is squared, then we also have to square that. So let me write the co-function identity that we are going to use for this one. Co-function identity. It is cotangent of pi over 2 minus u equals tan of u, but obviously we are not using u, all right? So we're going to change this, since we got a cotangent squared pi over 2 minus y. We're going to change our u's to y, but not only that, since it's squared, we're going to also change our tan to square. Y. All right, here we go. 5 secant squared y minus 5. I'm about to replace all of that stuff, that co-function, left part of the co-function identity, with the right side, which is tan squared y. We're trying to prove that this equals 5. What do you think we can do to the left side? Let's just do the left hand side. What do you think we can do right now with 5 secant squared y minus 5 tangent squared y? Well, at least one thing we can do.
Factor out the 5.
I would say factor out the 5, showing up twice. All right, secant squared y minus tan squared y. And I know we can use an identity somehow. Secant squared y is equal to what?
1 plus tan squared y.
1 plus tan squared y minus another tan squared y. So this cancels, leaving us with just that 5 times 1, which equals 5, which is the right-hand side that we were trying to prove.